that might need to be tweaked now if it turns out that the universe is older than we think. Hey, Professor, I'm thinking of some of my favorites, the God equation, physics of the future, future of humanity. Most of them say the universe is about 13 billion years old. What if it's not?
Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe.
It's hard to believe that just 90 years ago, we were unaware of the vast majority of the universe beyond our own Milky Way. In fact, many astronomers believed the Milky Way contained all the stars in existence. In 1917, Harlow Shapley and Heber Curtis observed a nova, a sudden bright flare that appeared to be a new star in what was then known as the Andromeda Nebula. Novas usually appeared suddenly and would fade over the course of weeks or months. This sparked Curtis's curiosity, leading him to search for additional novas in photographic records. He found 11 more of these phenomena, but what truly sparked his curiosity was observing that novas in Andromeda appeared significantly fainter than those in the Milky Way. This observation led Curtis to estimate that Andromeda was 500,000 light-years away. Consequently, he became a strong supporter of the island universes hypothesis, which proposed that what were once thought to be spiral nebulae within the Milky Way were actually separate galaxies. This was a groundbreaking moment for both humanity and cosmology, although at the time, we still believed the universe was unchanging. Albert Einstein even added something called a cosmological constant to his equations to make sure the universe stayed still. Cut to 1928, and Edwin Hubble's measurements of galaxies led him to the realization that the universe was uniformly expanding. This observation implied that the universe possesses a finite age, and this age could be estimated by mathematically going back in time. With this, Edwin Hubble first estimated the universe to be only 2 billion years old, which we now know is way off from the universe's actual age. The detection of cosmic microwave background radiation in 1965 marked the resolution of the lingering scientific doubts about the expanding universe. While it was now confirmed that the universe was indeed expanding, the precise rate of this expansion remained unclear for several decades. Disagreements about the exact expansion rate led to an intense debate, with estimates varying between 8 billion and 18 billion years. The discrepancy in the calculations became clearer when scientists started determining the ages of the oldest main sequence stars, discovering that they were over 8 billion years old. This posed a logical problem, as stars cannot be older than the universe itself, leading cosmology to a standstill. However, in 1997, the Hubble Space Telescope's observations broke through this impasse by revealing that the universe's expansion was not occurring at a constant rate, but rather accelerating, driven by an unknown repulsive force called dark energy. When dark energy is factored into the universe's expansion history, astronomers arrive at an age for the universe of 13.8 billion years. But there is a problem. A parameter used in cosmology to describe the rate of the universe's expansion, known as the Hubble constant, is still a topic of debate. According to fundamental physics and cosmic background radiation, scientists estimate the Hubble constant to be about 68 kilometers per second per megaparsec. However, this value doesn't align with observations of stars and galaxies in our local universe. So that raises the question: what if everything we thought we knew about our universe's age is only a partial truth? Brace yourselves, for here is a shocking discovery. A group of stars in the Milky Way appears to be as old as the universe, or maybe older. The star cluster M92, a densely packed group of stars located approximately 27,000 light-years from Earth, is estimated to be around 13.8 billion years old. This updated age estimate aligns the cluster's age with that of the universe itself. This finding could potentially challenge current estimations of the universe's age and help establish a limit, offering new insights into its evolution. The age is at the edge of what has been estimated by other researchers, said astronomer Martin Ying from Dartmouth College. It helps us define the minimum age of the universe, as we wouldn't expect the star cluster to have formed before the universe itself. Globular clusters, such as M92, consist of densely packed groups of stars believed to have formed simultaneously, simplifying the task of determining their ages. For astronomers, stars follow different life paths depending on their mass at birth. Larger stars burn through their fuel quickly and have shorter lifespans, while smaller stars endure for longer periods. Understanding how many stars in a cluster have transitioned beyond their primary fuel-burning phase provides insights into when the entire cluster originated. Age estimations for stars have traditionally been based on assumptions about stellar evolution. To find a more accurate approach, Yang and his team used a computer to create 20,000 synthetic stellar populations for M92, with each one representing a possible age for the cluster. They then compared the colors and brightness of each synthetic population with data from the Hubble Space Telescope, identifying the age that best matched the observed information. Although M92's age has been measured previously, earlier estimates relied on just one synthetic star population. By comparing thousands of synthetic populations, the researchers significantly reduced the uncertainty associated with assumptions inherent in each model. This novel technique resulted in a 50% reduction in the uncertainty of the cluster's age. The team determined that M92 is approximately 13.8 billion years old, with a margin of error of around 750 million years. Interestingly, this age closely matches the most widely accepted estimate for the age of the universe, just over 13.8 billion years, with an error margin of about 24 million years. One way to resolve this discrepancy is to consider a different age for the universe. If we take the Hubble tension seriously, it suggests that we may not actually have a precise understanding of the universe's age. This discovery draws attention back to a recent study from the University of Ottawa, which proposes that the universe is not 13.8 billion years old, but rather 26.7 billion years old. In short, the new model highlights the presence of stars like Methuselah, which seem to be older than the estimated age of the universe, as well as the discovery of early galaxies using the James Webb Space Telescope. These galaxies, observed just 300 million years after the Big Bang, show a level of maturity and mass that would usually be linked to billions of years of cosmic evolution, posing a major mystery. Advancements in computing, theoretical insights, and more accurate measurements of cluster distances like M92, along with the discovery of primordial galaxies from the Dark Age, have raised new questions. What are your thoughts? Could the universe be older than 13.8 billion years? Do we need to rethink our approach? Interestingly, renowned physicist Michio Kaku predicted this possibility a year ago.